Welcome to Probability Part 3. By now you all must be well versed with what probability is. So today we are going to do some more problems on that, and when the data is given in a tabular format, that also how we find out the probability we will see. This is the very first question. Two coins were tossed simultaneously 200 times and two heads appear 115 times. One head appears 35 times and no head appears the rest of the time. That means out of 200, 115 times only two heads are occurring, 35 times no head is occurring, one head is occurring, and so no head means 115 plus 35, that makes it 150, and 200 minus 150, that will give me 50. As of now I am writing that no head appears 50 times. So the first question is, find the probability of getting two heads. See, it has been mentioned very clearly that the total is 200. So I write 200 in the denominator. And now getting two heads. Two heads appear 115 times. So I write 115 here. And then reduce it to lowest term. It goes with 5. 5 2s are and 5 3s are 15. 5 2s are 10. 15 3. By 4 and 23 by 40 is my required probability. Second part, probability of getting at least one head. At least one head means 1 minus 0 head. 1 minus 0 head. 0 head is coming 50 times. So the probability here, I am writing here, it will be 1 minus 50 by 200. 200 will remain in the denominator as it was the total outcomes. And 1 minus 50 by 200 because it's written at least one head. So no head, 1 minus 0 head. So this will be 150 upon 200, and then once again we reduce it to lowest term, 3 by 4. The third part, probability of getting exactly one head. See, exactly one head has been written. Two heads appear 115 times, one head appears 35 times. So that means out of 200, exactly one head is appearing 35 times. And 35 divided by 200 will be the required probability. Once again, we reduce it to lowest term. 5 7s are 540. So this is how we calculate the probability of getting two heads, at least one head, and exactly one head. We move on to another problem. In this question, we know that a die is thrown 100 times, and as we all know that the die has only 6 outcomes, a number between 1 and 6. So the frequency is given in a tabular form. See, the number 1 appears 25 times, number 2 appears 12 times, and so on. So this is the frequency, and when we total them, it comes to be 100 because the die is thrown 100 times. And the probability of getting an even number. So as we see, 2, 4 and 6. These are the even numbers that can appear on a die. So what we do is, the total number of outcomes we first write in the denominator, that is 100, and then add up the frequency of 2, 4 and 6. This is 12, 20 and 10. So what I do is, I am adding them up, 12, 20 and 10, and what I get is 30, 42 by 100. Or 0.42. This will be my required probability of getting an even number on a die when it is thrown 100 times. Second part, probability of getting more than 4. More than 4 means that I have to get either a 5 or a 6 on the die. So that means probability of getting 5 plus probability of getting 6 will be added up. So probability of getting 5 is 18 by 100. And this is 6 by 100. Sorry, 10 by 100. So this will be 18 by 100 or 18 plus 10 by 100. See, the frequency is 18 here. The frequency is 10 here. So what we do is, probability of 5 is added to probability of getting 6. And the probability of getting 5 is 18 by 100. And here it is 10 by 100. So I add them up and I get 28 by 100. That means 0.28. This will be the required probability of getting a number more than 4 on a die when it is thrown 100 times. We get this one. Probability of getting 1 or 3. So now what we have to find out is how many times am I getting 1 and how many times am I getting 3. So these probabilities will be added up just like this. Here it was more than 4, here it is getting 1 or 3. So the probability of getting 1 is, I'll write probability of getting 1 on probability or probability of getting 3. These two probabilities are added up when there is an odd word used in between. So 25 by 100 plus 15 by 100. This is what I get as 40 by 100. That means 0.4. 0.4 is the required probability of getting 1 or 3. Here, the probability of getting a multiple of 3. So you have to be very careful. The 3 and 6 both are to be considered. So the probability of getting 3 as known as 15 and here is the 10. Probability of getting 3 plus probability of getting 6 will be 15 plus 10. This will be 25 by 100. That means it will be 0.25. This will be the required probability of getting a multiple of 3. So in these kind of questions, we have to be very careful how it is written, like the tabular format has been given. Maybe sometimes this is not given. Suppose this is not given to us. 10 is not given. But we know that the total number of times the coin has been tossed, the die has been tossed 100 times. So when we know that the die has been tossed 100 times, we add them up and subtract from 100. That means 100 minus this total. So this total will come to be 90. 100 minus 90 will give me this value. This can be the missing value as well. So here is another example where the marks obtained by the students has been given in a tabular format. See, the marks obtained between 0 to 30 is 15 students are scoring that. 30 to 50, 25 students and so on. But the total will always be 100 because the total number of students are 100. Let's get going. Find the probability that the students scored 70 to 90%. From the table, it is very clear that 70 to 90% has been scored only by 30 students. So the denominator will be 100 because there are total 100 students. And those who are scoring between 70 and 90 is 30. So this will be 0.3. 0.3 will be the probability that the students are getting marks between 70 to 90 out of 100 students. Let's see this one. Probability of scoring more than 70. More than 70 means 70 and above. So these two will be counted. Because 70 to 90 and 90 to 100 as well will be counted. So what will be the total probability? 30 by 100 plus 7 by 100. That means it will be 37 by 100 or 0.37. Because two probabilities are getting added up here. 70 to 90, 90 to 100. We see this part. Probability of scoring less than 70. See, here it was more than 70 and here it is less than 70. So there are two methods. Either we add them up from here onwards 25, 15 or less than 17. That means this also will be added up. 23, 25 and 15 will be added up. Or else 1 minus probability of getting more than 70. 1 minus probability of getting more than 70 we already have. So what we can do is 1 minus 0.37 or 0.63. Directly we can get because more than 70 we already have and we want less than 70. So 1 minus probability of getting more than 70 will give me the probability of getting less than 70% marks. Now the last part is probability of passing. Probability of passing given that 30 are the pass marks. So we have to be very careful here. 30 is the pass mark. So from here onwards, people are passing. So less than 30, that means 0 to 30 will be the probability that students are failing. And we want to find out the probability of pass marks. So what we can do is 1 minus 15 by 100. Because as I said, either I add them up 25, 23, 30 and 7. Either I add them up or else 1 minus 0.15. 1 minus 0.15 because this is the probability that students are failing. From here they are failing and onwards they are passing. So 1 minus, this will be always easier. So it is 0.85. This method is always easier because instead of adding all these numbers, because now they are small numbers, they can be very big numbers. So instead of adding them, just subtract 1 minus, which is not required. This was the required probability and this was the not required probability that we just wanted to discard. So this is how we calculate probability from a tabular format. In coming parts also, we'll be dealing with more and more problems related to this. Hope you are liking all our videos. So, send in your suggestions and queries in the comment box, share the videos with your friends and press the bell icon for the latest information on all the videos of Maths and English. And don't forget to subscribe the channel Idea Infinity.